This is Dan Abbott. I am making this as my final video for the CAD Management class, AED260 at Southern Maine Community College. This is the capstone project where you're going to automatically update up to, well, the most I've ever done is 4,000 drawings at a time without any intervention. And that requires that you use three things: a script file, a batch file, and a list file. You've dealt with all of them. You know what they all do, so we'll go through that process. I'm going to give you several examples. I also have a video on my YouTube channel of my latest project, which is the most extensive. And that is something I want you to watch as well, so you can see what the kind of possibilities are for that. But let's just start with why this whole thing works. In the first place, let's start with the batch file, because that's what kicks things off. If I were to go to the DOS command prompt, you can start an application at the DOS command prompt by using the start function. So if I say start and I type in something that's a registered, especially if it's a Microsoft Office type project, like WinWord. WinWord is the executable file, as you know, from the PGP assignment where you had to do external commands. WinWord.exe is how you start Microsoft Word. So if I type start WinWord, it'll start Microsoft Word for me. That's because it was registered. If I try saying start ACAD, well, let's start AutoCAD. If I say let's start AutoCAD, it's not going to know what to do because AutoCAD is not the name of the executable file that starts AutoCAD. It's ACAD. However, if I say start ACAD, it still doesn't know what to do because it is not a Microsoft product that isn't registered in the same way, which means I have to tell it exactly where to find the acad.exe file. Now, not only do I have to do that, but I also have to make sure that I quote any reference that has a space in it. So if there's a folder name that has a space in it, the folder name itself has to be quoted. So what that would look like, I'm going to go and open up a batch file for some examples that I have. So if I open up, this is on the C drive, I open up the blockout BAT file by editing it. Don't forget, don't open it because it'll just run the batch file. The location for AutoCAD, I have AutoCAD 2020 on my computer. The location is on the C drive, Program Files, Autodesk, AutoCAD 2020, and there's a space here, there's a space between Program and Files, and then EXE. So if I were to take that line right there, and I go back to DOS, and I'm just going to, didn't open up DOS, there we go. If I go back here and right click, and paste it, which is what just happened. And then I go in front of it and type in start, go to the end like this. If I type that and enter, an internal and external command. Oh, I made a mistake. Let me put the word start first, and then I'll paste. What I did was I inadvertently put the word start between C:\\, and backslash. So I just made a mistake. I didn't do it intentionally, although I don't mind making mistakes on videos because I think it helps to show you how to troubleshoot them. I know start is a recognized internal command, but it doesn't say start, it says C:\, backslash. So I simply inserted that in the wrong place. Now if I press enter, it starts AutoCAD because it can find the acad.exe file and it starts it up. Well, there are a couple other things about AutoCAD and about starting from the DOS prompt, and that includes the fact that, well, forget this %% for right now. You can also, when you do start AutoCAD, if you put a switch B after the start function and then identify a script, it'll start AutoCAD and run that script. So all the scripts that you created that were setup type scripts, you could actually have them run at AutoCAD startup every single time. Now, if you were using I'm just going back to my desktop. If you were using the icon to start AutoCAD up at the desktop, and that would be, I'm just going to close a few windows here because while I'm recording I can't get to the desktop link at the bottom of the screen. But eventually, there we go. You can go to the AutoCAD icon that starts AutoCAD on your desktop and you can change the properties. When you do that, you can have it run a certain script when you start it up. So if you look in Target has the path that I just used. Now, by the way, it's quoted here. The whole thing is quoted, but you can't do that at the DOS command prompt. You have to quote the individual folder name. Program files has to have quotes around program and files. And then AutoCAD 2022 has to have quotes around that. So it's a different syntax. But if you look here, you've got a few switches in here as well. But I could replace that with a /B and the name and location of a script file. And now when I double click on that icon, AutoCAD would start up with that script file. So we're going to take advantage of that fact, because what we want to do is automatically open a series of drawings in AutoCAD, run a script, and the script will then do things. And the script will do things including loading and running an AutoLISP program. And that's how the whole thing is going to get connected. So this process requires that you have a batch file to fire off AutoCAD, that you have a script file to do something when an AutoCAD drawing is opened, and a list file because it gives you more control over what gets done than a script alone, although there are a number of things that I've done that use only a script. But it's a lot more effective to have a list file to do certain kinds of things. So you know what a script does. It's like typing things at the AutoCAD command prompt. Anything you can type in there can be run as a script. You've had enough experience with list files to know that you can do pretty much anything with lists, particularly if you start using the VL functions, which we haven't covered in this class. So those are the three things that you need. So just a few things here to just identify, possibilities. These are all things that I've done in the past, and I haven't added the most complex one, partly because it's so complex it's a little hard to describe. But that's the one that I have a video that I'm going to link to in our Brightspace page on YouTube. The first thing I ever did with this was reduce the file sizes of all drawings in a directory for someone. That's not quite true, actually. The first thing I ever did was opened up 4,000 drawings, exploited all the blocks in the drawings, exploited all the nested blocks in the drawings, exploited all the polylines in the drawings, and then saved the drawings back to a different format for a company that was converting from one program that they were using, which was a mainframe program, to, actually it was MicroStation in this case, but the process of converting from their mainframe to MicroStation resulted in changes in the way polylines were figured. The algorithm was different, and the company made packaging. So one of the things they made packaging for was eggs. And so the shape of the packaging was critical, and if it was wrong, then the eggs wouldn't be protected. So they had all these drawings that they were trying to convert. And it turns out that the most effective way of converting the drawings was to turn them into AutoCAD drawings first, and then save them out as files that could be opened up in MicroStation. That was pretty specialized. I doubt that I'll ever do that again. So these really are the things I've done that I consider to be more general in nature. So one of them is reducing the file size of all the drawings in a directory. That's not as big a deal now as it once was, but at one time storage was quite expensive, and companies would frequently run out of room on their computers or in their network for storing files. AutoCAD files can get bloated really fast, especially back in the old days, when if you put a hatch pattern in an AutoCAD drawing, an anonymous block was created, and the definition of that block was part of the drawing file, even if you deleted the hatch pattern. And one of the things that would happen is people would put in a hatch pattern that was such a small scale when they were drawing something architectural, for instance, that it would just fill in black with all these lines. Then they'd delete it, make a change, and the old one, the one that came in with a scale so small that it looked black, the definition would still be in there. Anyway, the point is, it would be real easy to fill up a hard drive back then. Not as big a deal now because storage is a lot cheaper. Another thing I've done, and this is a really common one, is when companies change ownership, they have all these archived drawings. And this came from a call. Somebody called me and said, listen, I kind of got in trouble. I pulled an old drawing, printed it out, shipped it out to someone, and I realized that the old company name was on the drawing because that was the title block. And I don't want to do that again and forget it. Is there any way to open every drawing we've ever done and replace the company name in the title block with our new company name? So that one is one that actually you could conceivably want to use when you're out working. The third one, and these are the first three of the ones that I have examples in the book, in your book for. The third one is somebody had a new CAD manager was hired at a company he worked for, and the new CAD manager, for some reason, didn't like the idea of symbol libraries being contained in single drawing files with multiple symbols that are related. Now, in my opinion, he was wrong. However, he was the new CAD manager. And so he had tasked somebody with the requirement that they open up every single symbol library drawing and then create a separate drawing file for each of the symbols in that symbol library. So instead of having a dozen symbol library drawings, each one of which contained related blocks, they had instead hundreds of drawing files in that folder, one for every individual block. I actually think he just didn't understand quite what he was doing, in my opinion. I think it makes much more sense to have left it the way it was. But this young man who was told to do that asked me for a little bit of help with it, but he had taken CAD Management, and so what we ended up doing was writing a series of programs that allowed him to just run it on all the drawings in their system, and all the drawings in their system then were opened and created individual drawings that the CAD Manager was then pleased to see had been done in, well, very little time. Other things that I've done that I don't have examples specifically for was adding attributes to existing block definitions, where you go through and say, we've got all these drawings and we have all these blocks that have attributes, and we realized we needed to add an additional attribute to every single block that was used in every single one of these drawings. And that's a question of opening up every drawing and then doing it manually. So automating that process was helpful to somebody. Just redefining existing block definitions. And we no longer use the block representing a window that we've been using for years. We want to replace every one of those with a new one. Layers that are bound from an XREF have this long name on them, and you know that if you bind an XREF layer, if you bind an XREF, all the layer names, the dimension style names, the text style names have the name of the drawing appended with a $0, $, or $1 maybe. And so a company realized that they had just this mess of bound XREFs with these layer names that made no sense, and they want to just go in and rename all the layer names in all the drawings. This one was interesting. A company that had hired one of our students, this was probably in the early 90s or late 80s, and because he was one of our students, he immediately said, hey, we need to create a block for our title block and not just a bunch of lines and text, and hey, why don't we put attributes in it so that you can just double click on it and put in the title, put in the project name, etc. So he did that. And then he called and said, okay, we've got hundreds of drawings now I've done since working here, and I've got attributes on all of them because you said to. But now what they want is a single file that lists every single drawing and all the data that's contained in those attributes. So in this case, what I did was wrote a series of programs that would open up every drawing, extract all the attribute data from the title blocks, place it in a text file, open up the next one and do the same thing and append it to the same text file. And when he got done running that, he had a single document that had all that data in it. And we also wrote it so he could then run it anytime he wanted to and just create a new text file. XREFs often have path changes, or sometimes have path changes, or images do as well. And that has caused people problems in the past. So another company just wanted to open up all their drawings and change the path for the XREFs and the images to relative from specific. There have been a number of other things that I've done with this, and a number of other things that other people have done with it. And after I wrote the book, probably the topic I got the most requests from people about was this one, and it was almost always people had trouble making it run. Part of it is they didn't follow specifically what the instructions were in your textbook, and then people would sometimes write and say, this is not running, and they'd send me an example, and I'd say, well, you quoted it incorrectly, and they'd write back and say, oh no, what you did isn't the right way to quote it, and I'd say, well, why don't you try it, and then they would, and it would work. I don't know why, but that one kind of annoyed me because it happened several times, and it was simply a question of being a little more diligent about transferring things over. Anyway, those are the possibilities. So I'm going to show you how to set one up. I'm going to run 3 of them, and then what your job is to identify some kind of change that would be reasonable or logical that could be applied, or that will be applied to every drawing you've ever done. And then you're going to run it. When you run it, you're going to record it using screencast, and then you're going to show me the results when you get done running it. So this is one of those things where normally I'd want you to do it in class and show us in class how it worked, but since we're not in class, you're going to do it instead as a screencast. If you think that that little image of me in the corner just changed, it's because I just paused everything and changed my lighting, because I have different lighting when I'm making recordings than I do when I'm working. I forgot. Alright, so here's what you need. A script file, which is going to be running when AutoCAD start AutoCAD. It's not going to start AutoCAD. It's going to be run when you start AutoCAD. And a script file can make changes directly. I actually wrote one of these one time for a company that was using AutoCAD-LT. That was tricky, but I figured out a way to do what they wanted. One of the things about this system, the way I have it set up, it never replaces existing drawings. And you absolutely never want an automated system to replace existing drawings. So if something goes wrong, you want those original drawings. And one of the things I've always done when I do it for somebody else is I require them to agree in writing that they will back up all the drawings before they run this. And then when I write these things, I write them in such a way that they don't replace existing drawings. They put new versions in a different location. And I build that right into the programming. So the chances of this overriding an existing drawing are really slim. But at any rate, you do not want to replace existing drawings when you do this. So that became a problem with somebody who had LT, because without AutoLISP, I had no way of pulling the drawing name out and then putting it into a different format and moving things to a different location. So I had to come up with a creative way to do that. But the point is, because AutoCAD-LT won't run Lisp programs, it all had to be done in a script. And what I did was actually changed. I actually opened these things up, went through and did the purging process, and then saved the drawings as template files in a specific location. And then I went to DOS, and in DOS renamed all the template files to DWG files. So as a result, I was able to save to a different location without having to use a Lisp program to do it. And we need a batch file, and again, this DOS isn't dead yet for me, and this is the biggest reason why. This would not work. This whole system would be completely inoperative if DOS did not exist and you didn't have a link to DOS batch files. I don't know in Windows how I would do this. I would have to be done by using Boot Camp or Parallels. But this is really why I think that a program like ours needs to include some experience with DOS before you leave. So there's a couple of reasons for using this. One is that I can create a new folder in the DOS batch file for putting the replacement drawings in. And there's a function in DOS called for. Now you've seen that function because when you did the annotation of the DOS batch files assignment, there were several examples of that you had to look up and describe. So the for function allows you to go through multiple files in a particular location and do the same thing to each file from a DOS point of view. It's also possible, and I'll show you this as well, to use the R switch for the for function and then go down through subdirectories as well as one directory. The examples I'm going to show you are going to use a single directory, and then I'll show you how you can modify that so that you can include all the subdirectories under that one directory. And then the list file, you can do almost anything, as you've probably figured out. So couple of things. Try these things out as you go. By the way, they're not going to work the first time, no matter how diligently you try copying what's in the book and then modifying it. This is exactly the kind of thing where you have to have some patience and a little curiosity and get kind of interested in solving problems. When it works finally, it's really exciting, at least it is for me. But in the process, things aren't going to work. You're going to have to try things, troubleshoot them, go back. Same thing I just did when I tried starting AutoCAD from the command prompt, and it gave me an error message. I made a mistake. You look at it, you figure out what it is, you make a mistake. And again, I've already said this, back up your originals, make new files with the process, don't delete the originals until you're done and you've had a chance to review it and make sure it does what you want. And all these new drawings should be in their own directory. These days, with as much storage as available for so little money, I would keep the originals in an archive folder forever, just in case. Troubleshooting. Oh, this is just an example. I've got a troubleshooting section in your book, and the AutoCAD Secrets Every User Should Know on page 260 and 261. So if things don't work, this is the way to go and try to look at it. Use the F2 key, look at the history, and think. This is the fun part. I've forgotten that I put that slide in here. So let's take a look first at a batch file, and I've got it here because it's a little easier to read. Then I'll go and look at an actual batch file. These are the two functions that are absolutely key to this. The first one is the for function, and what it does is allows you to set a variable. And in DOS terms, a variable is known as a replaceable parameter. And variables are replaceable parameters if they're typed in the format %, a letter of some kind, or a character of some kind, or %. The difference between % and %% is that if I were going to type at the command prompt and use the for function, the variable name can only have a single % symbol in front of the letter. If you're using a batch file, you need two of them. Why, I don't know. But don't worry about it, because you're not going to type this in at the command prompt unless you're just trying it out. Instead, you're going to write a batch file. So we're going to use the format %. Now the F is just like the letter X when you're doing algebra. It's a variable. It can stand for anything. In this case, I use the letter F because to me it feels like a good letter to represent a file name. So what we're going to do is set a series of file names in a directory equal to this variable, and then use that variable later on in the batch file to do something. So don't get confused by this. %% is simply the same thing as typing an X or a Y or a Z as a variable letter when you're doing math. Start wait is the other critical function. You saw me do the start function earlier. Start simply fires off something, and if you give it an executable file name, it'll fire off that program, the application that's identified with that executable file. If you put the /, and notice there's a space between start and / and none after the /, and again, a reminder, the / indicates that a switch is coming. And a switch is simply a way of modifying the behavior of the DOS command. In this case, what it says is start whatever's going to happen, and then wait till whatever is going to happen is done before moving to the next line in the batch file. And in this particular case, the for function is going to step through a series of files. So what you want it to do is to fire off AutoCAD, open the first file, do something, and then go to the next file. If you didn't put the wait in there, it would try to go to the next file immediately, and it would completely bung things up. So what you need is start space / wait in your batch file in order for it to work. Now the scripts, and again, you can make the scripts using VLisp, which is color-coded, Notepad, WordPad, Notepad++, as long as it's a text file. And probably you're going to use Notepad since that's what you're familiar with. I actually use VLisp for scripts, not because it's designed for scripts, but because it does do some color coding, automatically thinking I'm doing Lisp, and that's helpful to me sometimes. So you have to save it with an SCR extension, as you know. So if you use the switch /B, that means run the following script. The reason that /S isn't used instead of /B is that /S as a switch in AutoCAD already has another meaning assigned to it. So whatever command line input. So when you're trying out your script, first try it out at the command line and try it. Don't forget to use a dash at the command line for things like layer and insert so you can see how it works. If there is an option that comes up with save as, you have to turn file dia off in the script in order to try save as a script without opening a dialog box. And so the way this is going to be worded, AutoCAD 2011, you can see I've been doing this a long time. I actually developed this in 1991 or 92, and when I was a speaker for Autodesk University, which I did for 14 years, I did this workshop multiple times. And so this particular PowerPoint comes from the Autodesk University workshops that I did for them back in 2011. Anyway, if you fire up AutoCAD with the ACAD.exe file, and it's always ACAD.exe still, that hasn't changed, it's just the location of the file, and then indicate a path in the drawing name, that'll open up that drawing. AutoLISP, you know enough about AutoLISP, we can look at all kinds of things there. But what you're going to do with AutoLISP is say, what do I want to change in these drawings? I gave you some examples. What I want you to do is do something other than the first 3 examples, because those are in the book. You could just copy those and make it run, which would not be a bad way to just make sure you know how to make this work. And in fact, it would be a really good idea to start there, copy them, make sure they work, and then modify them to do what you want to do as opposed to what they do. The others that I gave you examples of, if you want to go ahead and try those, that's fine. I'll tell you another one I did that is not listed there. This was really interesting. It was 3 years ago. I got a contact from somebody in England, and they had all these drawings, and they had all been done in England, and they opened an office in New York, and they made cabinetry and, you know, file cabinets and all kinds of stuff. And it was essentially a furniture company for industrial and commercial furniture. And so they opened up an office in New York, and all their drawings were completely whacked because they were all done in metric. And because they're all done in metric, everything was coming in 25.42 times too big when they were trying to insert stuff. And they wanted to know, is there any way to go back to those drawings and modify them so they were no longer metric drawings, they were imperial drawings instead. So I assigned that to my class, this CAD Management class, as a problem. And we solved it and sent the files off to her, and she sent us a cabinet that they had made. A little red, white, and blue cabinet. Almost looked like it was made for the United States, but at any rate, so one of the things they wanted there was not only did they want to modify these, they also wanted a PDF file printed from every single layout. And I'll show you that process a little later on. So at any rate, there's a number of things you could do. Don't do what many students in the past have done, is call me and say, or write to me and say, what should I do? This is your job. I hired you. You think about AutoCAD, the way it works. You think about drawings, the kinds of things that might need to be updated. If you want to take a look at my list from the beginning, and when I say that, I mean this list right here, the first 3 are in the book verbatim. Those are not open to you. None of those, you can do them, but none of those are open to you as your capstone. So if you want to try doing the rest of these, or one of the others of these, then go right ahead. That's fine. But otherwise, think about it. What else could you do? Don't do something silly like put a face in it or put my name in it or something like that. Think seriously about what kind of modification might be valuable in a setting. And when you leave here, you'll take this with you and you'll have a little container. It's almost like a pie shell, and you can just pour your stuff into that container because you'll know exactly how to make it work. So let's go take a look now at the individual files. I've changed the resolution on my screen, so I'm hoping you'll be able to read that okay. So we're going to go and take a look first at my folder that I set up. Now I just set this up for the purpose of this demonstration. So I'm on the C drive. I got a folder in the C drive called Changing Hundreds. In that folder on the C drive, I added a folder called DWG, and I just placed some drawings in there just to have something to use. And these drawings consist of, well, a block that I'm going to use to modify the title block in all of those drawings, and then a number of other drawings that just have a bunch of stuff in them. One of them I made artificially inflated so that it's 2,000 meg in size, because we're going to go through and run the one that reduces the file size of everything. And then these are all symbols files that came from AutoCAD that all have individual blocks in it, because I'm going to use those to demonstrate how to the process of exporting all those individual block files into individual drawing files. So right now, under drawing in that folder, all I have is drawings. There's nothing else in here. The code, we don't need that. That's just the code that I have here, and I put it here instead just so we can take a look at it. Now, one of the things is you're going to have 3 files for your project. It's a really good idea, although not necessary, but it's a really good idea to give them all the same name, and the only difference being the extension. BAT for the batch file, LSP for the list program, and SCR for the script. It's a good idea only because it's easier for you to keep track. It doesn't matter what you name these things as long as you identify them correctly in each of the files that does actually call them or identify them. There's one here which is the core version, And that's something that I probably won't do much with because it looked really promising when they came up with this alternative some years ago. But it does not work in the way that I think it should. Therefore, I probably won't deal with it. So anyway, so we've got blockout is one of the programs. Border, which is going to update the title block using a border block. And then the WB out is I'm using W block as a way of reducing the file size of everything. That file right there just gets added because I'm in Google Drive. All right, so all I've got right here right now are all the files that I need, a folder called DWG, and in that folder is some drawings. So now what I'm going to do first is open up Blockout BAT and take a look at it. Now it's got a few things going. One is right at the very top as a remark, it's got the name of the file. Not a bad idea, but it's a remark, so nothing is going to happen. Then I turn echo off just for that line right there. Then I clear the screen. That's what CLS does, just to make it something brand new so there's nothing else cluttering the screen. And then I echo what is essentially just a series of comments. And what it does is it explains what this thing does. It's meant to work with other files, and the other files are called Blockout Script and Blockout LSP. Use it at your own risk. You can remember that from the whole disclaimer on Lisp programs. When you start running this, the only way to stop a batch file is to let it run through or press Control-C or close the window. Now, as a result, I have a pause built in, so when you first run this, you see all these comments, but it doesn't do anything until you press Enter. Now, I've got this specifically keyed to the folder that I'm in on the C drive, and then I'm going to go into the DWG folder. So this is designed to run on a group of files in a single folder. It does not deal with their subfolders. And then new blocks is the name of a new folder that I'm going to put inside the DWG folder. So what's going to happen when I first run this batch file, it's going to make a folder location for me that doesn't exist so that I can put my drawings in that folder. I called it new blocks because that's where they're going to go. Now, this is the for function right here. And let me pull that over so we can see it, the whole thing. Can we? Yes, we can. So what this is going to do is say for whatever is represented by that variable name. Again, in DOS it's called a replaceable parameter. So whatever is in there, and that's going to be the name of a file. And where's that file come from? And again, this is the syntax. Just duplicate it when you do this. For %% and if you use F, that's fine, but you have to make sure it's the same letter you use over here. You can use whatever letter you want. F makes sense to me. By the way, if it's lowercase here, it has to be lowercase there. Now, in parentheses, go and look in that folder, and that folder is the DWG folder that I just showed you. For every file in there that starts with SYM and ends in anything, and those are all the 5 symbol files. Those came from AutoCAD. They're all symbols. So, and then the extension is put there as well. So I've got a wildcard here. So every single drawing in that folder that starts with the letters SYM are going to be assigned to that variable name. And once they are, that variable name is going to be used down here to not only start AutoCAD, but to start AutoCAD with a specific file. Did I say folder name? I meant file name. So what are we going to do with each one of those? We're going to do the following. We're going to start an application. Then we're going to wait for it to be done so we don't interfere with that process until it's all over. What are we going to do? Well, I had to tell it where to find the ACAD.exe file. So we're going to go to the C drive, Program Files, and notice the quotes are around Program Files and not around the entire line. I had many people, well, a number, write and tell me they couldn't run this and it wasn't working because they were putting quotes here and here instead of on the individual folder names because they were convinced that that was the right way to do it and that I'd made a mistake in the book. There's no mistake. Everything in that book runs. And I know that because Paul Richardson checked every single one of them and made sure that they ran. I also had a technical editor for the publisher as well. Not nearly as effective as Paul was, but it got well vetted. So don't go making changes here without understanding what you're doing. So quote Program Files because there's a space there. AutoCAD 2022, and again, that's the release I happen to have. You need to use your own release number. I also had somebody contact me because it wouldn't run because they didn't have the same release that I had in the book, which was 2007, 2006. The point is you have to understand what you're doing here. You're trying to run AutoCAD as it exists on your computer. If you decide to install it in a different location, this is not going to work. This is the default install location. So wherever your AutoCAD-EXE file is, that's what you have to identify here. Now you run the program and then open a specific file name. Now that file name right there, you notice is in quotes. Over here it's not in quotes. Why? It doesn't matter over here. It just gives you the name of a file. But if your file name, the drawing itself, has a space in it, the only way it'll run here is if the file is quoted. So I put quotes there just because this would only work without quotes for file names with no spaces. And since many file names have spaces, it makes sense to quote them here. No quotes here though. Don't put the quotes here, it won't work. You can leave the quotes here off and it'll work as long as every file that you're trying to process has no space in it. Otherwise, if it hits one with a space, it'll break the program. It'll just stop and go, we don't know what to do. Front/B means when you open that drawing, run the following script. The script is also in the same location. That's convenient, but again, this can be anywhere and be called anywhere as long as the location or the path you give here and the name you give here is actually the path and the name of the script you want to run. At this point, if we were in class, I'd say, does that make sense to everybody, and give you a chance to ask questions, but we're not in class, so I can't do that. What I'm going to do now is take a look at the script. So I'll just close that out, and I'll go to the script file, and I'll right-click on that, and I'll open it. Now this script file is quite simple. Has the same thing I did before. Instead of REM, of course, which is a DOS remark, I use a semicolon in a script. That's how you prevent the script from trying to run something. So I have the name of the script. I put my name here. This one is, this particular example I created in 2006. But again, I have some that go back to the early 1990s, I mean. And then I have, again, some information about what it is. And I have a misspelling right here. It doesn't really matter, but I don't like misspelling, so I'm going to change it. So the script file meant to work with an AutoLISP file just to explain what it does. Anyone without express or implied warranty. Now we get down here, and this is where it runs. So what's the script going to do? It's going to load a Lisp program. Now, to do that, we're using Lisp code. That's why there's a parenthesis there. You've all done Lisp now. So if you're doing Lisp, you cannot use a backslash. You have to use a double backslash or a front slash to separate folder names. So we're going to go to the C drive, the same location we're in now, and it's going to load that Lisp program. Once it loads it, there'll be a new command created by that Lisp program, so then it'll run that command. Then it will quit out of AutoCAD. And this is a little weird because this is really based on the way AutoCAD once worked, but no longer does. So if you were to type quit, it doesn't behave quite the same. In this case, the word quit back in the old days would come up with a, do you really mean you want to quit? And you'd have to say yes. So if I look at this, highlight all the way down, the last line is where the blinking cursor is. There's no, well, all this is just remarks anyway. So down here, there's no spaces at the end. The space at the end would be the enter key. And this won't work if I leave the cursor up there. The cursor has to be down at the end of the line. That's just the way scripts are. So we'll close that one out. So now, what does that block out Lisp program do? Actually, I'm going to save this because I corrected the, well, that might be a mistake. I might have done something else here too. We'll find out when I try to run it. Now I want to look at the Lisp program. Since I have AutoCAD open anyway, and I don't really want it open when I'm running it, what I'm going to do is just go in. Do I have a drawing in here? Yeah, I've got a drawing open. I'm just going to use VList just so you can see the color coding on this. So I'm just now going to open up that file that's on my C drive. And it's in the Changing Hundreds folder that I created. And it is Blockout Lisp. So again, you can open this any way you want, but I just wanted you to be able to see the color coding of it. And I think you can probably read that okay, but just in case, let's do that. Okay, here we go. So again, I've got a little header material at the top with a semicolon. So what does this thing do? It creates a command called blockout. And then here, those are all local variables, and so I put those in the parentheses with a front slash, a space, and then the names of the variables. Each of those variables is being used in this program. So what does the first thing do? It gets the current drawing name. And it gets the current drawing name because what I want to do is to save the drawings in a new location but with the same name that they currently have. So in order to do that, there's a variable in AutoCAD called dwg name, which will give you the name of the current drawing, just the name of the drawing. So I'm going to set that equal to dn, which I consider drawing name. Now, this is I use these short variables that I created here just so it would all fit on one screen and be easier to talk about. I probably, if I were really doing this, would have called that drawing name with n having uppercase and then just copying and pasting it. But I also need to find out where that drawing is. And to find out where the drawing is, you have to get the variable Dwg Prefix. So I'm setting that equal to path, PA for path. So I have the name of the drawing, current name, and I have the path. And let's just make sure you understand what I'm doing with that. I'm going to go back to AutoCAD. And in AutoCAD, the drawing that I have open right now is called Drawing 1. I'm going to do a Save As. So I'll do a Save As. I'll put this in my Documents folder, and I'll call it Demo 1, so you know it's different. So if you look up here now, it's got a path statement. It's also got the name Demo 1. So if I type in DWG prefix right now, it pops up and tells me the prefix for the drawing I'm in is C:\users\Dan\documents. That's where it is right now. It's using single backslashes because that's not that's not a Lisp program. Then if I say DWG name and do that, it tells me the name of the drawing, including the extension on it. So if you want to save that in Lisp, you say set a variable, and the variable can be whatever. Say I do this, although hang on. Not what I would normally do. So set var, set q, and then dwg name equal to drawing name. So if I do that, I've now created a variable. I got that backwards. I knew I did. Or I should have known I did. Drawing name. So I'm going to say set drawing name equal to get var drawing name. So the get var drawing name is going to get the current name of the drawing, and the set q is going to set it equal to. I do that, and it returns demo1.dwg. So that's all that Lisp program is doing right now. Go back to the Lisp program. And let's go back to the magnifier so there's no problem with you reading it on your screen. So now, what I'm going to do is take advantage of the fact that I know that I'm going to create in my batch file a new folder called new blocks, which is where I want all these things to go. So what I'm going to do is to create a new drawing name and path by adding together the drawing name, the existing path, and then adding into that a folder name that is being created by the batch file. Now I could have created that manually, but I'm going to do it in the batch file to make sure it's there. In order to do that, I need to put all three of those things together. So those are all strings, and so I'm going to create string 1, which is what I mean S1 to be. I'm going to put them all together into a single string, which I need, by concatenating them, by gluing them together. So string cat is going to glue together all these strings. So what am I gluing together? PA, which is the current path. I'm going to add to that new blocks double backslash. Now double backslash, I'm going to use this in Lisp. And then I'm going to add dn. So if I were to do this, I'm going to load that. And what did I do with my, over here? Oh, I just reinstalled AutoCAD, so things are a little different now. So I've got the name of the drawing. Then I load this. And now I've got the path of the drawing right here. and then I do the string cat, and I put all those things together. Now I've got a new drawing name that's C:\\/users\\/Dan documents. That's the old path. I appended to that a new location, new blocks, and then the drawing name. And the reason is I'm going to use that drawing name to save the individual drawings. Now this is something that's new to you, and that's the table next function. And what I'm going to do here is go through a table of block names and go and look at every single block name. And that means block names no matter what their name is. So I'm going to set a new variable, block data, equal to the name of every single block in this drawing. And true just means no matter what, even if it's got spaces in it. And now while there's a value there, while there is a block listed in that table, so let's just say we have a table with 3 block names. While is going to run 3 times. It's going to go, okay, take the first item in that table. So if I have a block called block 1, it's going to do something with it. Come back up. If there's another block left, block 2, it's going to do the same thing to that one. Then it's going to go back through, come back up, and if there's a third block, it's going to do the same thing to that one, because now that means that block data has a value because I'm setting it equal to the name of every block in the drawing. The next time it comes back up, if the table has been exhausted, there are no more block names, it is done, and then it moves on. So here's what it does. While there's any value there, it's going to go. This, I'm not going to explain this exactly, but what it does is pulls the actual block name out. And then it creates a full name by string concatenating this up here with the block name. What that means is I'm creating new drawings of every single block, and I need to give the drawing that I'm creating a drawing name, and I want the drawing name to be the same as the block name. In order to pull the block name out, even though I said the table lists the block names, I'm talking there in terms of internal code used to identify the blocks. They're actually not the name that I gave the blocks. To get the name I gave the blocks, I need to use this cater function and ASOC2, which is the block name. So that block data is, I don't know why I made that capital. It doesn't really matter, but it looks like it's different, but it isn't. So it goes into the block, the first block, and it finds the actual name given to that block, and it has more than just the name. It has something else associated with it, so I strip it of that, and now what I have here for block name is just the actual name that I used to make that, to name that block. Now here's the thing, if you're going to duplicate this, you could say, I don't know, it works, let's just put it in there. Right? Now I go down to the wblock command, which as you know is misnamed. It's really a save command, not a block command. And it's going to allow me to create a new W block consisting of the full block name. And it's going to then, and again, what it's doing here is asking what's the name of the block that I'm using. And the name of the block that I'm using is that full name. And that full name is going to be based on the name of the block in the table. What's S1? Oh yeah, S1 is up here. Okay, so in other words, when you do wblock, it asks you, where do you want to put it and what do you want to call it? Not even that. What do you want to put it? What do you want to call it? What's the name of the block you're doing this in? Let's go back over to AutoCAD just to make sure that you understand what I'm doing with that. So this particular drawing doesn't happen to have any blocks in it, so I'm going to make a block. I'm going to make a block. It's going to be called circle, and I'll just create it like this, and I'll select the items, and I'll convert it to a block. So now I have a block here, and that block is not a circle, it's a block that contains a circle. So if I use the wblock command, and I do it at the command line, it comes up. In order to make sure this is going to happen, I have to turn file dia off. If I turn file dia off, I go wblock at the command prompt and ask me what's the name of the output file. That's where I need both the path and the name I'm trying to save this as. So whatever name I give this, circles, that's the name of the file. It already exists? Sure, let's replace it. Now, What are we going to define it with, the whole drawing? Are we going to use a block name, right? And back there it asks for the name of an existing block. So what we would have had to do there is give the name circles. So we have two pieces of information we need to provide the wblock command. The name of the drawing file we're creating with wblock and the name of the block whose contents we're going to use in that drawing. And again, wblock has nothing to do with blocks unless you do this. Otherwise, it's just a way of saving part of an existing drawing. We could have picked some entities, we could have saved the entire drawing, and you'll see that later, or we can save the contents of an existing block definition, the contents, as its own drawing file. And that's what this program is doing. Go back to this, and so at this point it has now created a drawing from the first block. Then it goes down here and it sets block data equal to, make that bigger, sends block data, which is the same variable I used up here. So it had the name of the first block. Once it gets done with the first block, now I set block data equal to table next. Table next means the next item in the table that lists all the blocks in the drawing. So it'll go to the second block, which means block data has a value associated with it. So while there's a value associated, it does this. So now that's got a new value, and it goes through and does the same thing. So it creates a file, a drawing file, from the contents of the next block. And it goes through that till there are no more blocks, and then it's done. When it's done, when it's done, if we look at the script that we had opened up, it goes back and quits out of AutoCAD. And once it quits out of AutoCAD, DOS gets control back and goes on to the next drawing file. So that's what the whole thing looks like. What I'm going to do is close AutoCAD altogether. You don't want AutoCAD open when you do this because it's going to open automatically. So now we have almost an hour. Well, this is a big deal. This is a difficult one. So I'm just going to remind you that all I have in here right now is a folder full of drawings called DWG, and outside I've got the content of what I'm using to make this all work. I'm going to start with a batch file. It comes up and it gives me that information, and it says press any key to continue because I used a pause in there. I do that, it goes and opens up AutoCAD. Now I've got my hands in the air. I'm not doing anything. I could be outside, I could be in my house. I could have started this on a Friday. Oh, okay, this is a wrinkle. The wrinkle is this: it's loading a Lisp program, and because AutoCAD has this new security feature where it won't load Lisp programs from anything other than a trusted source, I overlooked something. I can say always load from this source, which is what I'm going to do. But prior to going into this, what I could have done is added that location. In fact, let's just do that. Yeah, I'm going to close that out. I'm going to close AutoCAD out. I'm going to close my batch file out. So now I'm going to go back to AutoCAD, and I'm just going to add the location that it's pulling that Lisp program out of as a trusted source under options. This was not a problem when I first wrote the book because that didn't exist. That whole idea, that security function didn't exist. But in order to change that, what I have to do is start a new file and go to Options and Options. There we go. And under Options, under Files, there's a listing of trusted locations. Right now, the trusted locations are fairly limited. I'm going to add a new trusted location. And the new trusted location, I'll browse to it just so you can see what I'm doing, but it's the C drive. And it is here. And it is in Changing Hundreds. And that is the location, so I'm just going to add that. It's not read-only. That's okay. It's trying to protect me from malicious code is what it's doing. So I'm going to do that, and I'll move that up. And it doesn't go any higher than this because those two are defaults. So now I'll apply that. I'll pick OK. I'll get back out of AutoCAD, and if everything goes well, I should not get that error message this time. Let me just make sure. So you notice, by the way, the batch file ran long enough to create a new block folder. However, it didn't actually put anything in it. So I'll delete that and go back. Didn't put anything in it because it never ran long enough to do it. Now we'll try that again. Do the batch file. I'll sit back. If this was something where I had 1,000 drawings to do, I'd be going home now and letting it do its thing. It's going to open AutoCAD. It's doing something there that was so fast you didn't even see it. Comes back to DOS, opens AutoCAD again, and goes to the next drawing that matches the syntax in the batch file, which means it's got to be a drawing in C:\changing hundreds \DWG that starts with SYM. And what's happening when this is running in the upper left-hand corner is it's flashing through every block definition that it is making a drawing file out of. And I know this is, we're just sitting here for a minute, but we're not going to be here all weekend. I'm going to let this go. It'll be about another 30 seconds or so. I think I had 5 drawings in there. So it'll open up again right now. And I think this is the last one, or maybe one more. The core function that I mentioned before I thought was going to be awesome because it is a non-graphical interface way of running AutoCAD. It's like having a command line but not seeing anything in the drawing editor. And it is really fast. And it does work really well in the situations where it works. The problem is it will not load and then run a Lisp program. I don't know why, but it won't. It should. It seems to me. Anyway, now it's done. So what happened? Well, if I open this up, there's this new folder called New Blocks. Symbols, SYM, 1, 2, yeah, so it ran 5 times. If I open up New Blocks, it is filled with these new blocks. And the new blocks I made have the name of the drawing, and I left the DWG in there just because it was easier to explain. There's a way I could have stripped that out. So I just string concatenated the name of the drawing and then the name of the block that was in the drawing. So if I take a look, see if there's anything of any interest here. So landscaping, picnic table. So if I open that file up right now, the file I open up is going to be just what was in the picnic table block in that symbols library drawing. Now, one of the things that people often expect when they open up one of these drawings is they expect to find a block in the drawing, and there will be no blocks in this drawing because I didn't make this out of a block that contained blocks in its definition. Instead, here we go, get rid of that. There's a picnic table. This is not a block. There are no blocks in this drawing. If I go to block edit, there's nothing in here because it didn't make a block. It made a drawing file. And to make the drawing file, it went to the contents of a block named picnic table. And the contents of the block named picnic table consisted of only lines. So the drawing consists of only lines. If there were a nested block inside this definition, yes, we'd have a block that would have been in the block that was being defined called picnic table. But it isn't. So now every single one, we'll close this out, every single one of the blocks that was in every single one of these symbols drawings has now been created. Now let's take a look at a couple of other examples. Go back to changing hundreds. So now we have the border one. This is really an interesting one. And I'll show you, by the way, let me go back here. I have a drawing called border. And what I'm doing is I'm going to replace an existing title block with a replacement one. This was a little odd. This company had a really weird way of drawing borders. I don't recommend it, but that's what they did. And I, by the way, changed the name of everything. They had a border that was square. And when they brought it in, they'd bring it in with a different aspect ratio so that it would match any size sheet of paper. I just think that's weird. And one of the reasons it's weird is it distorts everything when you do that. I mean, in other words, right now this looks a certain way, but when you bring it in, it's going to be longer than it is tall. Well, this is not their existing title block, and I'm pretending KDS is the name of a company I once had with some people where we did some computer stuff. So I called this KDS Industries, a subsidiary of Autodesk University, blah, blah, blah. So I just made this name up. But I wanted a logo that was round, and in order to make it round when it came in, I had to make it elliptical in this particular drawing. But this is the replacement title block. This is the title block they wanted, and it's identical to the title block they used except for all the company name. So what they wanted was to replace existing title blocks with this title block in all the drawings they had on their system. Now, there are attributes here. A lot of this is just text, but there were attributes inserted, and the attributes inserted have to be exactly the same name. Actually, maybe this one didn't have any attributes. I don't see them. Yeah, I think what I did is modified this later on, because after I did this for them, they said, well, we've got attributes in the existing drawings. How do we capture those as well? So this new one has to have the same attribute names in them. As long as they're the same names, the values that are in the original are going to be assigned here. So that's what this one looks like. If we take a look and open up, if we take a look and open up one of the drawings, the ones that start with D, see this is what their title block looks like right now. So you can see at SMTC, at the time I did this, we were Southern Maine Technical College. So this happened to be a paper company. So anyway, I just made up this block. So you can see this whole block. If I double click it, it doesn't have any attributes in it. So what I did for my example was without attributes. But this does work with attributes. So what I want is when I'm done, I want this to have been replaced with the new stuff, and I wanted the logo to be circular. But you can see that this is not a square title block. In fact, there is no such thing as a square title block. My feeling on title blocks is make one for each sheet size, period. Don't try to do a single title block that fits every different sheet size, because you're going to end up with some distortion. So at any rate, so what I want to do is replace in all of these drawings that start with D. I might start with D and some numbers as well. What I want to do is replace the title block in every single one of these. So I'm going to close AutoCAD up, because when I run this, I don't want AutoCAD open. Now I go back, and you notice there are 4 drawings. 5 drawings that start with the letter D and some numbers. And I'll leave this one where it is. We'll go back to changing hundreds, and then border bat. Okay, so now we're going to edit that and take a look at it. So this one also just barely fits here. So again, I use the same syntax. I would just copy this and bring it over, put a little information up here about what it is. And by the way, you can just copy and paste this stuff and then modify it for your own if you want. That's a smart way to use programming that already exists. I'm going to make another new folder called new border. Same syntax for every file, %% in that location, starting with D5 and ending in anything. So the idea here is we can be selective. Do the following: start and wait for it to finish the AutoCAD-LT file, and then open up a drawing, quoted in case there are any spaces in the drawing name, and then run the script, border script. So that's what the batch file does. We go down to the border script, right click and open that. And what does that do? It inserts, this is interesting, because the easiest way for me to do this was to use a command line version of this, where all the work is actually done at the command line. I'm going to say insert border equal to. Well, in every one of these drawings is a title block named border. That's the name of their title block. If you say at the command line you want to insert and you give the name of an existing block, in this case border, and then an equal sign and make it equal to the name of a drawing file, that drawing file will be used to redefine that block. Now this is a script, which means there's no way for me to actually wait for input from the operator. So what I'm doing here is inserting border equals that file right there, the drawing named border. Doesn't have to be the same name either, by the way. Probably I should have made them different names to clarify that. But again, that is the name of the border, is the name of the existing block in the AutoCAD drawing, the existing title block. This is a drawing of the new title block. When this gets done with the insert command, the old border title block in that drawing will be redefined with whatever is in this drawing, whatever's in there. Now, what that means is you have to build it so the insertion point and all the other things about it are identical to the one that you started with. Now, you have to follow through on this. So I put it at 0, 0, 1, 1, 0. Those are X, Y, and then rotation. Well, I don't really want it in the drawing, but I have to go through and follow through, because there's no way to just cancel right here and then have this continue. So it goes and it puts that new title block in, sticks it down in the corner, and then erase last L for last, erases what just got inserted. Then I go and load a Lisp program that is designed only to give this new drawing a different name. So I load it, and it creates a new program, a new command called border. I run the command called border, then I quit, and then I go here, and again, you'll notice that that ends right down here. Quit, yes, I really mean it. Now I'll take care of that. We'll take a look at the Lisp program. This one is simple enough Lisp program, so probably we can just open it up here without having to look at it in VLisp. Oh, actually, I've got Notepad ++ here for this one, so we can still actually see this. And this is good because it's bigger. So once again, there's a Lisp program, so I got the semicolons for the comments, and then I'm defining a new command. The new command is called border. Those are the variables that I use. They're local variables. Again, I get the drawing name just like I did last time. I get the drawing prefix just like I did last time. I create a new drawing name by string concatenating the existing path, new border, which is the folder that's being created by my batch file, with the double \n because it has to be there, and then the drawing name. And then I just go and say save that. So there's my new variable name right here. New variable name. This is actually pretty cool. I never noticed that before. Notepad ++. If you double click on a variable, it shows you where all of them are used. That is really helpful. I wish VLisp did that. Love it. Anyway, so it saves that drawing name. That's all it does. So let's go and run that one. Oh, this is interesting. I never modified that batch file. The last one I modified. So here's my error message. Oh my God, it's not working. Oh, I don't have AutoCAD 2020 on this computer. I have AutoCAD 2021. I also have AutoCAD 2022. So if I cancel this, you notice it's going to go through that 5 times and tell me, no, we can't find it. All I have to do now is go in and say, all right, let's give that a different name. Now, by the way, how do I know where that is? Well, I just know, but you can go and look for it. But again, when you install this, if you decided, I don't like where it's going to put it and put it someplace else, this isn't going to work. Now I'll save that. Try it one more time. Comes up like this, finds it, and it runs it. I like these little mistakes. I think it's helpful to you. Now, when it opens up the drawing, if you watch really carefully, no, you can't see it. It goes too fast. That's okay. It goes too fast for a reason. I'll show you when we open them up. But what it's doing right now is it is replacing the existing block called border, and the title blocks on these are going to all be updated. So I'll let it run through. By the way, there's a message back here that a subdirectory already exists called border, or new border, whatever I call that folder name. And the reason it does is because I ran this twice. The first time it failed, but it did make the directory. The good news is it doesn't matter. It won't break. It won't stop if there's already a folder with that name. It just continues on. And I think one more time we'll do it. Yeah, I wish that core function had worked as the way I wanted it to, because boy, it was fast, really fast, because you didn't have to wait for it to open up to show the splash screen, to have AutoCAD open up the whole thing. But the thing is, you're not going to be here for this. If you're running one of these, you're going to start it and then go do something else. Now, DWG, there's a new border folder in addition to the new blocks folder. I go in here, and the same drawing names that occurred back here. But if I look at the first one, the one that we started with, the title block in the first one looks like this. Okay, looks like that. Now let's go open the title block in the second, in the new version. So I go to new border, open up the same drawing in the new border, and it looks like this. So what it did is replace the existing title block with this one. And you'll notice this is the title block. Yeah, these things were in the drawing originally, and they weren't part of the title block. But that's okay, because this came in exactly the same insertion point with the same scale factor. And you notice, by the way, this is now round. And what I had to do to make that happen, and I wanted to make a point to them why I thought it was such a weird thing to make a title block that you have to scale differently in the X and Y. I had to go back and draw that so it was elliptical in order for that, logo to come in. And that's just a logo I use because it's cool looking, I think. All right, so that's what happened with all those, and they all did that. Now, we'll go back and do the last one. And the last one is a DB out. W block out is what that stands for. And this is using W block just to reduce file sizes. So if we go and look, it's going to do this to all of these drawings. But I created one in particular, drawing 3. And if you look at it, 2,453 kilobytes. So what's in this drawing that makes it a drawing that has some size to it? If we open it up and look at it, you'll see what's in this drawing is nothing. Nothing drawn in here at all. Why is it so big? Well, it's got a bunch of layer names. In fact, I could make it even bigger by adding more layers right now, but I'll do that later. It's also probably got block definitions in it. Got a bunch of block definitions. They're pretty good sized block definitions. I probably also, I can't remember, but I probably also loaded line types. Yeah, so I've loaded some line types in here. Probably some text, a bunch of text styles in here. So I just did that just to make a point that you can have drawings that are pretty bloated without any actual entities in the drawing. So the idea here is to try to make a drawing as small as possible by getting rid of the things you don't use. The purge command could be used for this, by the way. And there is a purge command at the command prompt that would let you be selective in the program as it's written. But W block star, if I say I want to go to W block, I have to turn off file dia again, and then dash W block. So if I do this, and I say, what's the name of the output file, and I say that, it says, what do you want? If I put an asterisk here, it defines this new drawing with only what's necessary to support the entities in the drawing. No entities in the drawing. When I'm done, I'll get rid of all the layer names, I'll get rid of all the text styles, etc. So this would reduce a file down to its absolutely smallest possible size and still support the entities that are in that drawing. So I'm just going to throw this away, and we'll go back. You notice there's no folder for these. I'll go back to changing hundreds, and we'll take a look at each of them in turn as a reminder. So the batch file in this one will look very familiar. In the batch file on this one, give the name of the batch file. Turns echo off. That's just, never mind what that does. It just, well, you actually know what that does. That was in the annotation assignment you had to do. So it's making a new folder in this location called dwg \wb. And then for every file in that folder location, every file, in this case all drawing files, do the following. Start AutoCAD, wait for it to be done. It's AutoCAD because it's here. Once again though, I have to modify this to the current release. And then I quote that because it's possible drawing files have spaces in them. /B means run the script. Doesn't matter. That space didn't for anything. And then when you do, open the drawing and then run the WB out script. So this time I have to save that because I changed the path. Now I go to the script file, and what happens when it opens the script is this. It loads the program called wbout.lsp, does a zoom all, runs WB out, and then quits. Now why does it do a zoom all? Because for some weird reason, if you try to create a drawing using W block, or save, and nothing has changed in that drawing, in other words, you open it and then go to save it, it will not save a new version of it unless something happened after you opened it. Whether that's still true or not, I don't know, but it was when I wrote this. So I do a zoom all just to have done something. Doesn't make any difference, but I do. And by the way, when I do the zoom all, when it does save, it will save with everything zoomed out. So it's going to load the program created by that Lisp program, do a zoom all, run the new command, and then again quit, yes, and then there's got to be a return at the end. The reason I keep emphasizing this is that it's so frustrating for students when they forget that and nothing works and nothing works and nothing works. And I've seen that happen so many times in the past years that I just want to make sure you don't get frustrated by the fact that this doesn't work just because you didn't press enter at the end of that line. Now, what does this list program do? I'll open that up in Notepad++ once again, and this is quite a simple one. It defines a new command called wbout. Again, / the variable names used. Saw this before. Go and get the name of the current drawing. Save it to a variable. Go and get the prefix of the current drawing. Save it to a variable. Make a new drawing name and path by concatenating together the original path, the new folder name WB, which was created by the batch file, the double backslash because it's going to be in a list program, and then the name of the drawing. Then command wblock. There's the path WBDN. That's my idea of a variable name that was easy to remember. And by the way, again, you double click on it, they all highlight. I'm really pleased to discover that. I may start using this. Okay, and then what's the asterisk do? Saves everything. So it's really simple, very simple, and could be done, by the way, in AutoCAD-LT if you can come up with a workaround for saving it in the new location. So now, batch file again, do that. It doesn't give me the error message on trusted locations because I've already made this a trusted location. They're all in the same place. I'm going to open it up, and this is really going to be quick once it gets it open. If the core function would work on this correctly, this would be done by now, because it doesn't take long once it opens. But all the stuff that's happening now, the splash screen, the loading of all these things, all that stuff, the core console eliminates, which is why it's so frustrating that it doesn't work. But it doesn't, so that's the way it is. Again, though, I'm not going to be around for this. If I'm really doing this to 1,000 drawings, there's no way I'm going to sit here and watch that go through 1,000 drawings. I'm going to sit and watch it go through 4 or 5. In fact, when you test this, folks, just put together a little group of drawings, maybe 4 or 5 drawings, something like what I've done here, and run it on those first, just to make sure that it's working the way you want it to work. Now, once this is done, we'll take a look at that, and then I'm going to take a look at a much more involved version of this, and I want to show you how to have it modified so it goes through subdirectories as well as the root directory that you're pointing to. That requires a syntax change in the way the for command works, and it's not a simple syntax change like putting a /s. In fact, it doesn't use S for the switch for subdirectories, it uses an R. But you actually change the whole format of the command itself in order for that to work. Anyway, we'll take a look at that so you can see how to make that work as well. Once you got the subdirectory thing down, you could start at the C drive, for instance, and literally have it deal with every single file in your C drive. If I were doing this on a network, there's almost always a network drive that's common to people working in a particular office. If I have the rights to make those changes, you could go through and apply this to every single drawing in the entire organization that is on that one drive. And if you wanted to, you could just make your batch file have multiple lines in it and have it run once on the C drive, once on the X drive, once on the F drive, however many drives you have. You could build that all in your batch file and literally affect every single file in your organization without anybody being there. One of the things, by the way, that I recommend when people do this is that they use a computer that's on an uninterrupted power supply. So if this is one of those things that's going to take hours to run, you don't have the power going out in the middle of it and then having the whole thing crash. And most companies do have, in fact, any company of any size is going to have an uninterrupted power supply in their entire system. So at school, we have an uninterrupted power supply, massive battery version in the basement of our building, and that protects all the computer labs from losing power. I have a relatively large uninterrupted power supply in my office here at home where I'm teaching from, because if the power goes out suddenly, I don't want to lose what I'm working on. And I have one at school in my office just in case, because my office isn't protected since it's not a lab. And I have another one in the office beside me for the printer that we use there, the commercial printer, so that it won't lose power if something goes out. Now you can see this is taking a little longer because it has to open up every drawing. I didn't limit this to just individual drawings. On the other hand, if I wanted to cancel this, Control C would cancel this. If I didn't want to do Control C, I could do that. So I'm just going to cancel it because it should have done what I wanted, WB. Now, let's take a look here at these drawings. In particular, drawing 3, which is the one I just opened up. If we take a look at WB, all these drawings, including drawing 3, are now much, much smaller. Drawing 1 didn't get much smaller because most of what it had in it were entities. These other drawings didn't get much smaller. Let's just see, symbols landscaping. Went from 81 to 64 because there wasn't a whole lot to get rid of there. But there was a little bit. So right now, these drawings take up a whole lot less space than the other ones did. And again, 3 was the classic because there's nothing in there. That's the size of a completely empty drawing because it needs to have some size in order to exist as a file at all. So that's how all these things work. So I go back to the PowerPoint that I started with, which is actually a PDF file, and I'll include that in the assignment just so you have it. The rest of this, though, is really designed. When I did this as a workshop for Autodesk University, there were the active lab workshops, so everybody was at a computer. So I would go through this, and then I would have people type this stuff in and make these things work. And we didn't end until everybody had gotten them to work. So, you know, they do include slides showing how to do each one of these things. This is exactly what I just showed you for all of the different programs. So if you get on through here, all this does now is it goes through each example, explains what it does, and basically what I just did. So that's it there for your reference. And and here, this is nice. I'd forgotten I did that. Yeah, so if you take a look at this, I did this because it's possible if you have dimensions and hatches in blocks that it would actually break this program the way it was written. So what I did here was added code to show you what you could do to prevent that from happening. But I'm glad I looked at this. The problem is that a dimension is a block, and it's listed in the block table, but it's listed with an asterisk in front of it because it's an anonymous block. In other words, you didn't create it and name it. AutoCAD created it when you placed a dimension. Hatches are the same way. They're both anonymous blocks, and they require an asterisk in front of it. The reason this program would normally work without worrying about this is normally what you're doing is extracting block definitions from a symbol library, which means there'd be no hatch patterns and no dimensions in it because it's not an actual drawing. It's simply a repository for your block definitions. However, if you wanted to, you could do this, and it tells you exactly what happens here. And so I won't go through this right now in any detail. Well, let me just briefly tell you what it does. Substring allows you to go and alter a string by looking at different elements of the string. So a string is just a bunch of characters. You can go and you can get rid of certain characters. strlen, string length, is how you figure out how many characters are there in that variable name. That variable name is a drawing name, which, by the way, includes .dwg. .dwg is 4 characters. So I can get rid of the last 4 characters in that string and then substitute the result back to dn. And that would be a way of stripping the file extension off. And then, down here you got an if statement. Now the if statement says if that's true. Well, what is that? That means not equal to. So if the first block name, if block name doesn't start with an asterisk and then first location. So it says start with the first character and go 1 character over. If the first character in the block name is not an asterisk, do this. If it is an asterisk, skip this. The Progan concept here groups together all of the elements from the opening parenthesis to the closing parenthesis of Progan. And that means if true, do everything starting here and ending here. If false, skip things starting here and ending here and just go down here, which means it then looks at the next table and the next block in the block table. So it's literally going through and saying, if it starts with an asterisk, don't do anything. Go to the next one. Asterisk, next one. Asterisk, next one. Asterisk, next one. No asterisk, do something. And what are you going to do? Set the full name, set it equal to, save it, etc. That's a nice little piece of code there. I should probably put that in my example. But now you've seen it. So now, and then error trapping. If you have anything that changes variable names, it's a good idea to put error trapping in just in case something happens while this is running and it doesn't cause a problem of some kind. But the chances of this having to have error trapping are pretty slim if you do it right. But anyway, that's what's there. So what I want to do now is I want to take a look at another version. I want to show you what I did to make it go through all the drawings in a series of subdirectories. And I'll point out what it does. And there's a much more extensive video on that on my YouTube channel. And I'll also put a link to that on Brightspace. So here are the group of files in this project. And the idea of this project was quite involved. Company has many thousands and thousands of assets, which are things like valves and pumps, etc., in all kinds of places all over the city. And when a technician goes out to do a repair, they need to have data about, say, a pump. Well, in order to get that data about that one pump, they have to be in contact with either a database or somebody who has contact with a database back with where the primary files are kept. So if they're in the field and they're saying, I want to repair this, but I need some information about it, first they have to identify which pump it is. That normally would be done on an AutoCAD drawing where it would be laid out and you could identify it. Then somebody, them or someone else, has to go to the database of all the data about all the assets and match that one asset with the database asset, where they then can pull out information about the size of the pump, the horsepower, the manufacturer, etc. Possibly even a link to a repair manual of some kind. So right now that process takes a little bit of back and forth, more than a little bit of back and forth. So the idea here was if they could put a PDF file together of an AutoCAD drawing and put on a tablet, go in the field, pull up the drawing of that facility, find the particular asset that they're looking at, particular appliance, click on it, have a hyperlink that would then link to an URL, Universal Resource Locator, in other words, a website. And that website URL goes back to the server, back at the main office, where there's a database, matches the database with that particular asset by scanning through the entire database, and then finding the value, the information necessary for that, and then displaying it in that URL. That would save them a considerable amount of time and make them much more efficient. So the problem here is this. In order to make that happen, first somebody has to open the AutoCAD drawing. They have to go to every block in that drawing. They have to modify all the attributes in that block. Not all, they don't have to modify them necessarily, but they probably have to go in, at least in this particular case, have to go in and rename some attributes and make them more uniform, because right now there's some variation. They then have to attach a hyperlink to that block. And the hyperlink attached to that block has to go back to the Universal Resource Locator site, the website that is set up as the database is. But in order to do that, there are a number of other things that had to happen. For one thing, the blocks themselves had attributes on them, but sometimes they'd been inserted before an attribute was modified or before the block was modified, so they had to synchronize all the blocks that were already in the drawing. The order in which the blocks attributes were identified was not always in an order that was consistent, so it had to be reordered to be consistent. And they did have to create a new attribute value that could be linked to the hyperlink. And there were a number of other things that have to happen as well. So what I'm doing here is just giving you an example of how you would set this up so it dealt with all the drawings from one location all the way down through the subdirectories. So what I did here was I set up a folder called Hyperlink PWD. And in that folder, there is another folder called Lucidity Test. And in that folder, there's some drawings. And I made a subfolder in there with some drawings, and another subfolder with some drawings. Now these are all the same drawing. And they're the same drawing because all I'm doing is testing to see if I can make this go all the way down through. When I open this drawing, just to give you a sense of what this requires, and again I have a much longer video that deals with this entire project and goes step by step. When I open the drawing, it looks like this. We'll ignore that. It looks like this. So it's a P&ID drawing. But you notice there's a number of different sheets, and you'll also notice that there are a number of different layouts. So the problem is we need to not only make some changes to the way this is set up, but we also then have to create links, go to each layout, create a PDF file, and the PDF file has to have the links in them as well. So if we go and just take a look at any one of these assets, you have a, okay, we have a valve over here. If I double click on that valve has all these attributes associated with it. And it's got asset IDs, it's got a number of other things. Well, it turns out it needed, in order for this to work, the database is keyed to both a facility ID and an asset ID. So you had to combine those two values together into a separate attribute in order to search the attribute and then link it to the hyperlink. The other thing is there had to be some synchronization, because many of these blocks had been inserted, and then after they were inserted, the original block definition was altered. Well, because there are attributes attached, if you don't do an @sync, and I'll do a select here, if you don't do an @sync on a block after you've redefined it, the new definitions won't update to it. So you notice that had been redefined already, and had been redefined already to have this additional attribute, but it had never been synchronized, so the attribute wasn't available. So there are a number of things that have to happen here, and again, there's another video with a great deal more detail. But the simple form is somebody had to go in here, make modifications to the existing block definitions, attach a hyperlink to each of those blocks, and the hyperlink had to be keyed back to a particular spot. So the hyperlink had to know what that spot was, and the only way to know that is to have an asset ID that was linked to the database, and then to have a listing, a text-based listing of every single asset ID in the database available to compare this against. Time consuming. Then each of the layouts in this drawing had to have a PDF file created, which is a plotting function. So I'm going to close this up, and I'm going to show you one other thing about this before we take a look at the bash file. If you take a look here, I've got a Lisp program, but I also have this thing called an FAS file. An FAS file is a compiled Lisp program, and VLisp as a Lisp editor is capable of creating a compiled version. Well, a compiled version looks like this. If I were to open this up with Notepad, if I were to open this up with Notepad, it would be unreadable. It's what's known as machine language, and the reason it's machine language is because it's been compiled. So there is a little bit here. Do not change anything. There's a little bit of actual English up here, but most of it can only be read by a computer. What's the difference between that and this, which is exactly going to do exactly the same thing? This is a Lisp program. The difference is this program is in English. Well, in text, I won't say English. Which means somebody, if I were to give this to them, somebody could easily open this up and mess with it and then ruin the whole thing. It just wouldn't work anymore. So there's a pretty good reason to do compiled versions of programming so that people don't change it accidentally. But otherwise, we have the same thing. We have a batch file and a script file, and then a Lisp program, and there's two different versions of it here. The compiled version, which by the way you'll notice is much smaller, and the uncompiled version. Now the compiled version is also going to work faster, so it's a good idea in this case to do it anyway. But if we look at the batch file, because I have a folder that has subfolders and subfolders and subfolders, if I look at the batch file and edit it, I'm using a different format for the for function. And the format I'm using for the for function uses the /R as a switch for subdirectory, and the R comes from directory. And I don't know why it doesn't use an S for this. It would make sense to me, but it doesn't. Now, the format's also different. Instead of the for function being here, it's out here. It's the very first thing. So for, looking at all the subdirectories, and then the location is given first, then the replaceable parameter that's being used. And again, I could use any letter I wanted. I used F here and have to use it here as well. And then in parentheses are the drawing or the files that you want affected by the for function. So in this case, they're all drawing files. So it's literally going to look in this location, hyperlink pwd, which is the folder we just looked in, and all the subfolders in that folder for any drawing files, and then every time it finds one, and it's all alphanumerical, by the way, it looks at them from the top down in alphanumerical order. So 0, 0 would be the first one, 0, 1 would be the next one, and then when it got down to the numbers and went to the letters, then it would be A through Z. So start and wait, same thing it did before. Now nothing much changes after this syntax at the beginning. And then, again, program files has to be quoted. There's a space in it. Autodesk AutoCAD 2022 has to be quoted because there's a space in it. And then ACAD.exe is the executable file. Open up the file name represented by that variable, a replaceable parameter, run the script, and then I give the name of a script. So otherwise it's very much like what we just did. Close that out. Now if I look at the script, what the script is doing is this. The script is going to load a file. This is the compiled version of the Lisp file, but it's exactly the same as the Lisp file. That's what it does. And unlike the other programs that I showed you, instead of loading a Lisp program that has a single new command defined, this one has multiple new commands defined. So one of the multiple new commands is original asset ID. And then whatever that does, we can take a look at that, but that probably is for another day. This is a quite involved Lisp program. I'll open it and just show it to you, but we won't go through it step by step. Anyway, original asset ID does something. One of those things that has to be done otherwise by an operator, and it applies to everything. Then it goes down and runs a new command called full asset ID, also created in this Lisp program. And full asset ID creates a new ID based on the original ID plus the facility ID, puts them together into a full asset ID, and then uses that after sorting alphanumerically on all of them, and then synchronizing all of the blocks in the drawing. And then rotating the tags, because the synchronization brought many tags in so they were unreadable. So this program, tag rotate, is another command that puts everything so it's readable and applies to everything. And then asset ID invisible makes or changes the properties of the asset ID so that it is an invisible attribute and doesn't show all the time. And then it creates a hyperlink by running the command hyperlink pwd. Now the hyperlink pwd goes down and it uses this value right here, which is the value representing, and in case when I say value, I mean you go to and I need to make a change in that, don't I? What this is a text file, and the text file is a listing of all the asset IDs, and maybe that is actually, I'm going to make sure that's on my computer in the right place, otherwise what I have to do is change that path. So F:. So I'm just going to make sure that exists before I run this. And normally I would pause right now since I'm fumbling around so it doesn't look like I'm quite so fumbling, but I'm not going to do it this time just because, again, I want to make sure you understand that there's nothing illogical about this. But if I go to the F drive on this PC, is that going to be... No, the Google Drive now has got an H designation. So the reason this is significant is if I go to this is a Google Drive, so it's a mapped drive letter. And depending on how your computer is set up, that letter can change. So at one time when I was doing this, the letter that was mapped in Google Drive was an F, but now it's an H, so I need to change that. Otherwise, it goes to my drive, goes to our drive faculty, goes to Dan Abbott, plug it on to Dan Abbott, goes to PWD Lucidity, is that still here? It is not still here. So this would have broken if I had tried to run this. So what I'm going to do now is I'm going to actually pause this, and I'm going to change the path and put that file. What I need here is it needs to find that file right there. So I'm going to pause this, put that file in a location where I can find it, and then change this so that it's going to work. I am back and I've made this change. So now it's pointing to the right location to find that CSV file. And the CSV file, comma delimited file, let me show you what that is. This is a list of all the assets. So if I edit that, it is a text file that has a single line for every URL, and what's happening here is that specific ID that is attached to an attribute, and that's a facility ID as well as a asset ID. So you can see this is a partial listing, and I got a partial listing from the client so that I could try this out. But these are literally the locations of all the information about those IDs. So what this does is opens that up, goes to the list, finds a match to the hyperlink. I'm sorry, a match to the attribute for the full asset ID, and then creates a hyperlink with that URL in it, so it would go there when you pick the hyperlink. I think that's probably enough to start. We'll try it out, see how it goes. So now I'm going to go down through all the subdirectories on this. I hit enter and go through. I may have already made a trusted location for where this stuff is. We'll find out when it opens up, because it's going to have to go and load a Lisp program. So it loads it. It is trusted. It goes through. It's doing the @sync. It just did 5 of those things. It's now going to, and what you're looking at right now is the PDF files being created by every layout. That I can also fix. You wouldn't normally want it to actually display each one of these, but AutoCAD by default, if you use PDF as a plotter, by default it opens the file that it creates once it's done. So you notice it just opened and created a whole bunch, probably 10 hyperlink PDFs. So what you're looking at behind the AutoCAD screen is Adobe, and Adobe Acrobat Pro DC, and this is showing you all of the files that were created. So it's going to just fill my computer up here with PDF files. So what I'm going to do is I'm going to stop this. I'm going to stop it by going to the batch file and just closing the window if I'm a little quicker this time. Otherwise, it's just going to keep going. So now I've closed that out. Now if you take a look at these, first to see what it did, this is a PDF file. And if you go and hover over it, yeah, you'll notice right now when I hover over this, it lists one of those URLs that was on that listing. That's a hyperlink. If I were to click that, it's going to try to find that URL. Well, I don't have access to that because this is a client database. And although they gave me the actual CVS file, they certainly did not give me access to their server. And I wouldn't have wanted it if they'd asked me if I did. If I'm going to be messing with their server directly, we're going to have a whole different relationship. And that means I'm going to have to go work for them. But anyway, that is the URL that was assigned to that hyperlink. Which means now every single asset in that PDF file is linked to a specific URL. Now, what I'm going to do is close out all these tabs, and I'm going to show you what you can do if you decide to do something that involves creating PDF files. But I know it's all going to work, so I'm just going to go and close that now. Yes, I believe I do. That's not the one I wanted. Did I just close the wrong one? I want to make sure that I didn't just mess up. So let me open this script up again and make sure that it is correct. It is. Okay, so we're good. All right, so now what I'm going to do here is I'm going to go back to AutoCAD. I'm going to make a change. And I'm going to make a change so it doesn't automatically open a PDF file anytime you create one using the plot command, which is what it normally does. And then, yeah, we're going to have this. This is going to be under 2 hours. That's not bad. It's the first time I've ever done a recording, by the way, of this presentation. Okay, so I'm just going to go to a new drawing. In a new drawing, I'm going to go to File. And I actually could have done this outside of AutoCAD, but I'm going to do Plotter Manager. When I go to Plotter Manager, it opens up like this, and it gives me all of the PC3 files. And one of the PC3 files, the one I use, is DWG to PDF. I'm going to open that up. When I get done opening it up, I'm going to go over to Document Settings. And when I get to Document Settings, I'm going to go to Custom Properties, open that up, and then go to custom properties again. That's not normally open when you first do that. Let's start that again. Normally it's going to happen when you open that up. It's going to look like this. You go to document settings, custom properties, then you get the custom properties bar. Open that up, clear that, show results in viewer. And now every time you make a PDF file using DWG to PDF, it will not open the PDF file for you. So now that it's doing that, I'm going to go back and close AutoCAD. I'm going to clean up that folder of things that just got created. That's the hyperlink PWD. And so that folder right there was created. I'm going to get rid of it. And under lucidity test, yeah, those are fine. So what I'm doing here is this. Nothing is being affected that is already in existence. These drawings are not being affected at all. There'll be a whole new folder created, and that whole new folder that's been created is where these files are going to go. Now I'll do the batch file and run it. We'll sit back and then we'll take a look at the results. And again, the main reason I stopped that is because otherwise we're going to have hundreds of PDF files here. I think just so you don't have to sit and watch this thing run, I'll let it go through once and then I'm pausing it, and when it's done I'll come back and finish up the video. So you can see it's opening the drawing. It's going through and doing a bunch of stuff. All, by the way, without any input from me. And then it's going one layout at a time and creating the PDF. Now it's not opening them so you can see what happens next. Now it's going on to the next drawing. So I'm going to pause this because it might take 5 or 6 minutes for this to go. I'm going to pause it, and when it's done, I'm going to start the video again. Okay, that took about 5 minutes. Maybe just a little bit longer than that. Yeah, it took a little bit longer than that. Anyway, this is what happened in that 5 minutes. The drawings originally were here. So those are all the drawings we're dealing with the subdirectories, just to remind you. So now when I ran that, it created a new folder called hyperlink PWD. In that, it duplicated this folder arrangement. So there's one called Lucidity Test, and inside is another one called Lucidity Test 2. The original drawings are there. They're not changed at all. They're the same drawings. But there's also a folder full of PDF files. So every one of those is a PDF file. Open it up. Go to a someplace where there is a hyperlink, and they don't. All these blocks don't have hyperlinks on them. So there's one. But that does, and that hyperlink that's showing up in the PDF file is the direct URL back to the database. If you pick it, it'll try to go to it, and it can't find it because they don't have permission, so it looks like that. So we've now created, in that brief period of time, we've created all those PDF files, plus all those PDF files, plus all those PDF files. So what I did was, these are all nested down. You can see the amount of work that would have been involved with creating those files manually would have been daunting and tedious and filled with error, because tedious work where you do the same thing over and over again, that's when people start making mistakes. I think that's enough for this, and you've got enough to go on. Don't forget that I put on our drive, on our Google Drive, I put my entire book, which I know you have copies of, but in this book, that's where you can find, in chapter 3, I believe, not chapter 3, it is chapter 7, I'm sorry, the chapter on script, updating thousands of drawings. And I put in this chapter on scripts because it does use a script. Probably deserved its own chapter now that I think about it. Anyway, on page 258. So all the 3 that I gave you as samples, they're all laid out there. And you also have the Lisp code for those as well. I went a little too far here. Here we go, right here. We also have all the code that's on our drive as well. I wish there were hyperlinks in this document, but there aren't, and I didn't feel like putting them in. So at any rate, you've got the whole thing in here, and it is in chapter 7. That's chapter 6. Here we go. The script chapter. So if you get on through, you'll find that at the end of the chapter on scripts, you will see updating thousands of drawings, and it gives you the code right here. You can actually copy that code if you have Acrobat. In other words, you could go over here and do an edit PDF. When you do the edit PDF, it opens up the text, so you could literally go in here and do that. And then copy code if you wanted to. But you have to have Acrobat in order to do that. Or you could just type it in, which isn't a bad thing either. All right, I'm done with this. I'll be available at our next open session if you have any questions, and get working on this, and that is your capstone. You have to, when you get done and run it, use screencast from Autodesk to capture the process so I can see it run.